Dear students, let us discuss this question now. Let's see what does the question say here. So let us first read the question and understand what is being asked in the question. Okay. So the question says that a block of mass small m slides on the wooden wedge, okay, right, which in turn slides backwards, okay, on the horizontal surface, right. The acceleration of the block with respect to the wedge is. So they're asking about the acceleration of the block with respect to the wedge. Dear students, for solving these type of problems, obviously we will have to draw the free body diagram of the wedge as well as the block. So let us do that, okay. So let us do it for the block first. Okay, so this is the wedge, right? This is the wedge, dear students, right? And a block of some mass m is sliding. Let us assume that its acceleration is a2, okay. And if you assume an observer, on the wedge, and the wedge is moving with some, let's say, acceleration a1, okay, let's say some acceleration a1 towards left, then this observer is a non-inertial observer and he would definitely apply some pseudo force on the block, which is equal to mass of the block multiplied by acceleration of the observer opposite to the motion of the observer. So this is the pseudo force acting on the block, right, dear students. Now, and obviously this block small m is sliding down with some acceleration. Let us assume that to be a2, okay, right. Now this is theta, you know that this is mg would act vertically downwards. We would have mg cos theta. The component of weight down the inclined plane is mg sin theta. This is also theta, dear students, and definitely this component would be mg cos theta. We know that, right? Now there would be some normal acting perpendicular to the plane, right? And we would also have the components of this pseudo force, okay, right? And if this is theta, this is 90 minus theta, this should be theta, okay. Now the component of ma1 would be ma1 sin theta, dear students. And this component would actually be okay, this component would be, dear students, ma1 cos theta, which is down the inclined plane, ma1 cos theta, which is down the inclined plane, okay. Dear students, the block is not moving perpendicular to the inclined plane, okay. So we will write that summation fy must be 0 if this is an x-axis, okay, this is y-axis perpendicular to inclined plane. So for the block, summation fy must be 0 and summation fx is equal to mass times acceleration down the inclined plane, which is a2, okay. So summation fy must be 0. First thing to understand would be, obviously we are doing for the block, we are drawing the FBD, free body diagram for the block, and writing the force equation for the block, okay. Now normal reaction is in the upward direction, it is positive. ma1 sin theta must also be positive, and they together should balance mg cos theta, okay, right, dear students. So this is equation 1 for us, right. This is normal reaction is equal to mg cos theta minus ma1 sin theta. Let us take this as equation 1, okay, right. So we are taking this as equation 1, okay, right. Now also down the inclined plane, summation fx would be equal to mass of the block multiplied by acceleration of the block with respect to the wedge, okay, which is a2 here, okay. Now this is mg sin theta plus ma1 cos theta, okay. This is right. Now this is normal reaction plus ma sin theta must balance mg cos theta, right. Now this is mg sin theta plus ma1 cos theta, and that is definitely equal to ma2, right, dear students. I would like to cancel m from everywhere here, okay. So we have an equation now, g sin theta. Let us put the value of sin theta also. Theta is 30 degree in the question, so sin theta would be 1 upon 2, okay, right. And this would be a1, cos theta would definitely be √3 by 2, okay, and this is a2. So you have to basically find the value of a1, and substitute in this equation, and we would get A2, and A2 is what is asked in the question anyways. Now so we are done with this. Okay, now let us draw the free body diagram of wedge only. Okay, let us do that here. Okay, now for the wedge, dear students, this is theta, obviously this is 30 degree. Acceleration of the wedge towards left is a1. Okay, right, and this was the normal reaction. Now this was the normal reaction, right? Now this would be 90, this would be 90 minus theta, right? So if we take the components of normal reaction here, okay, if we take the components of normal reaction, this is 90 minus theta, this would also be 90 minus theta, this would be theta, dear students. So this would be n cos theta, and this would be actually n sin theta. Okay, right, this is n. So for the inclined plane, this n cos theta, dear students, this n cos theta would be balanced by the normal reaction provided by the table. So for the wedge, it would be n dash would be n cos theta plus the weight of the wooden wedge. However, I have written this summation Fy for this wedge also along the y-axis. I have taken x and y-axis separately here, right? Now, but this is not required in the question, so I am going to erase it. Okay, now you know that n sin theta is actually going to provide the horizontal force here. MA1 would be the case here, right? Now sin theta is 1 by 2, theta is 30 degree. Mass of the wedge is 16 kg, acceleration is a1. So I'm getting the value of normal reaction from here as 32 a1. So this would be another equation for us, right? So now I'm in a situation to erase the free body diagram here, and definitely we would put the values, and the aim is to find the value of A2 here. Okay, right. So first of all, we will replace the value of n, okay, and we will get A1 from there. So n is actually, so from equation first and third, definitely, dear students, n is 32 A1, n is 32 times A1. Mass of the block was 8 kg, 8 into g, cos theta is root 3 by 2, okay, right, minus, again mass of block is 8, acceleration is a1, sin theta is again 1 upon 2, okay, right. So this would come out to be 4 times a1 equals 2, okay, g root 3 by 2 minus a1 by 2, okay. So this would be, dear students, yes, this is 2 now. This is 4a1, this is g root 3 by 2, this is a1 by 2. Okay, right. We multiply the equation by 2 rather. Okay, so we would get 8a1 equals to g root 3 minus a1. So the a1 would come out to be g root 3 divided by 9, dear students. Okay, and now we are in a situation to replace the value of a1. Okay, this was equation 2, dear student. This was equation 2 rather. Okay, so this is equation 2. We would replace the value of a1 in equation 2, and we would get a2, and the value of a2 would be the answer for us. Okay, let us do that now. So now g by 2 plus a1 is g root 3 by 9. Okay, excuse me, multiplied by root 3 by 2 equals to a2 here. Okay, right. A1 was g root 3 by 9 multiplied by root 3 by 2, right, indeed. So dear students, again, let us solve the question further here. So this is coming out to be g by 2, this is coming out to be g by 6, okay, this is a2, we'll take the LCM now. This would be 3g plus g equals to a2. I'm getting the value of a2 as indeed 2g by 3, okay. So option 3 is surely going to be the right answer for us.